Welcome back, guys. Today I'm going to show you how to make a smart laser security system so that you can keep that cookie all to yourself. It is also highly customizable, so you can make a harder or easier maze depending on your ambition. In addition, it's also incredibly easy to make and ridiculously cheap. For this project, I am using the Arduino Uno. This is essentially the brains of the entire system. You can use different microcontrollers such as the Raspberry Pi or the BeagleBone, but hence how easy this project is, I went for the cheapest option. With the Arduino, there are two nodes subsiding with it, the photoresistor and the laser. Let's first start with the photoresistor. Here is the circuit involving the project. As you can see, it is incredibly simple. All we have here is a bus with a buzzer and photoresistor connected to digital pins 3 and 4. The reason we don't use analog pins here is because we want a simple Boolean state with our buzzer. Increasing the volume is a secondary feature that could be added, but right now we want to keep it simple. Here's an example. Let's say we have a light source. In this case, this will be our laser. This light source is what we will detect with the photoresistor. The photoresistor measures the light intensity and sends back a capacitance to the Arduino that we read as binary. For example, if the lights are on, we measure this as a 1. If the lights are off, we measure this as a 0. With this, we can turn on the buzzer based on what values we receive. The buzzer will beep if we get a 1, but will stop beeping if we get a 0. Coding the Arduino is also ridiculously simple. We code the Arduino using a language called the Arduino IDE, which is basically just a mix of Objective-C and C++. Even though the Arduino IDE isn't used anywhere else, it's easy enough to make up for it to learn it. In addition, it's surprisingly powerful. First, we start with our basic void setup function. We simply now set up our buzzer pins and photoresistor pins. I have mine selected as 3 and 4. Make sure that you are connecting these pins on the digital side, not the analog. Now we select our pin modes. The buzzer pin is obviously an output, while the photoresistor is obviously an input. With that finished, let's check out our void loop function. All we need to do here is add an if and else statement, with the condition that if the photoresistor gives back 0, then we turn the buzzer on. If the photoresistor gives back 1, we turn the buzzer off. In this case, however, I'm using a simple piezo with only one output. However, if you are using an advanced piezo, such as an active buzzer or a passive buzzer, you can adjust the tone. For example, you can adjust the frequency and the rate as well. Right here, we have a simple laser tripwire demonstration. All we are doing is pointing the laser at our circuit, specifically at the photoresistor. As you can see, when I put my hand inside the way, the buzzer will beep. Now, let's look back on our two nodes coming from the Arduino, the photoresistor and the laser. Let's check out the laser. Making this into a laser tripwire was relatively simple, but how do you make it into a maze? For this, we can use mirrors to reflect back the light from the laser. As you can see from the example, I am shining a laser at the mirror, and it's reflecting the light coming from it. You can find small mirrors for relatively cheap, and they don't break easily. Still, make sure you're extremely careful with them. Here's a simple example that I set up in my room. Additionally, it's pretty hard to see the lasers unless it's nighttime. This will make it extra hard for whoever you want to get away from your room. Thanks for watching. Now you have your own laser tripwire system.